Welcome everybody to week 5, day 1, IS50B. Today our topic is Niagara, the particle effects system. And I'm going to first demo something that my daughter and I made, mostly. My daughter and I, there were a couple other people that helped, but Mike made the gun, and Dolan made the splash screen, and basically everything else is my daughter and me. And so what we have here are some particle effects. And you can see that these laser zombies here, they kind of glow, and then over time they sort of fade away and turn invisible. And then they glow again. You can see they're hitting me, my health is going down. I can shoot them with my laser beam here. And I don't know if the audio is coming through, but they kind of disintegrate. Nope, there's still another one. That's what's kind of fun about it. And when they disintegrate, there's like a little cloud that like kind of keeps moving. You can see the particle effect on my character here. So he's outlined in a similar thing, except he's blue because he's good, whereas red indicates the bad guys. And so it's a cool little particle effect, tracing the outline of it. They're going to pathfind over here and maybe kill me if I'm not careful. So I'm going to kill them. You can see I've got, where it hits, it does a little splash of sparks and things like that. I also got a flamethrower like that. What do you think, Stover? You like that?
Yes, that is very nice.
So that's a cool little flamethrower kind of thing. I have a sprint button like that increases the running speed, and then if I die, it'll show the game over screen. You can see there's still plenty of laser zombies remaining. Let me let them kill me. Come here, come here. Pathfind over to me. And there we go. So then you die. And so Dolan made the splash screen. The gun in his hand was made by Mike, one of the guys at our college. That gun there. And then Ada and I basically did all the rest. Ada placed every one of those lights by hand, for example. I don't know what's going on with that texture. Oh, maybe that's the actual texture. Okay. Yeah, so Ada placed all of those lights by hand. It kind of looks cool, and she made a cool little, like, well right here and stuff like that. She built this staircase and the upstairs area, placed all those lights. And then I don't know why we have this here, but you know, who knows what goes through the mind of a 9-year-old, right? And you got some laser zombies over here, but the laser zombies can actually pathfind up the grass there, and so you'll find them kind of wander around the area. They sort of do a random walk if they can't find any targets. If they do find a target, then they pathfind towards them and attack. So that is the laser zombies game. It was a drastically scaled down project from what we originally intended. And even then, it took more time than expected, mostly because of the source control. Have you worked with source control before, Stover?
Nope, that is new to me as well.
Okay, so when you are working on a project with other people, what you want to do ideally is you want to be able to connect to source control, and you pick GitHub or usually Perforce is the go-to thing. And then what you do is, like, when you make a change, you hit save. Then there's an option to submit to source control. So if you make a change to a thing, it's like, hey, do you want to check this out? So yeah, check it out. And then you have ownership of that object. So if I wanted to mess with this thing over here, I could check it out, and then I could mess with it. And if anybody else went to check it out, it's like, sorry, Kearney has it right now. And so you're like, oh, okay. And so that stops you from stepping on each other's toes, which is a different model than what Git and GitHub use. In Git and GitHub, anybody can modify anything, and then you sort of run into these merge conflicts on the back end, and it doesn't work exactly very well for, it doesn't work at all for game development. And so there's something called Git LFS, Git Large File System, that sort of allows Git to work with large digital assets like this. Even still, it's not really recommended. So instead, what you want to do is just check out the files, the things you're going to work on, and then when you're done modifying it, like you mess with the textures, like you can see the texture here is misaligned. Maybe I messed with that. And then I hit submit to source control, and then it uploads that change back into the repository. And then other people can get an update of the changes, and then they kind of see it in their world. And so that allows you to collaborate and work together on it. And basically the week that I allotted to build this game, like 80% of it was just struggling getting Perforce to work because it constantly wanted to push, 100 or 200 gigs of data up to the repo, which saturated my net connection. The person on the other end, Dahlin, lives in like the backcountry somewhere, and so she couldn't sync her repository at all. It would have taken the entire week of her bandwidth to download it, and so she ended up just mailing me the image. Yeah. And eventually I just turned off Perforce. Like I'm done with this. And then the development went a lot faster. So Mike just sort of sent me the file for the gun, and I just imported it myself. And Dahlin sent me the file for the victory screen and the loss screen, and it turned out to be a lot faster than using Perforce, because it's really not designed for situations like these. You're really supposed to be in the same office, right? And everyone's on a high-speed LAN. You got 10 gigabit Ethernet, and everyone syncs the repository, so everybody's in sync with each other initially. Whereas she had to sync 200 gigs of data or whatever the unholy size of this thing was, which I don't even know how it was that big, because I didn't even import they had these like free assets and stuff to use. I didn't import like all of them. I imported some of them, and things like this, and it just exploded the file size out to like an unimaginable degree. So source control is the thing that I'm still waiting on, like a good transparent solution. It'd just be really neat if I could just have this work like Google Docs, where I could just slide it over here, and then you would be in the world and you would just see it slide over there too. You know what I mean? Like that would be nice, right?
Yeah, that's like the dream editor or game engine for anything, really.
Yeah, and so I hear that Unreal Engine 5 is doing something with source control to make it more transparent, but I haven't played around with it at all. And also, the repository hosting solutions are also really expensive. So we got a free repo from was it like DigitalOcean or something? Apologies to the company that gave the free server. I don't remember now. And it was reasonably easy to set up, and they had good bandwidth and things like that. But to do that after the game jam was over would have been expensive. It's actually quite pricey to run one in the cloud like that. So you'd have to set up one locally, and that's something that I'm kind of working with the school district a little bit on, to have a Perforce server or something locally in the district, that at least when people are working in the computer lab, they could share files with each other and things like that and get experience doing it. But we only have a few people, so it's not a big deal right now. All right, so that's, I guess, topic one, source control. It's very useful stuff. If you're going to be in tech in any way, shape, or fashion, you're going to be doing source control. Oftentimes Git when you're doing programming, but game development oftentimes runs on Perforce Helix server, and it's all right. I like I said, I ran into a lot of issues with it, and it would constantly be you have to re-upload all of your files. I'm like, you already have all the files. No, you have to re-upload all of them, and I'm like, it's 200 gigs. It's 200 gigs. My upload bandwidth is not that high, or at least it was before. I actually literally upgraded my internet because of that project last semester. Okay, so let's talk about Niagara. So Niagara, there's before we talk about Niagara, let's talk about the classic particle system. So one of the first things I usually do with students is I'll make a box trigger like this, and we'll make it a little bit bigger like that, and we'll make it a blueprint, and we'll be yo, explosion trigger. You know where I'm going with this, Stover?
Yeah.
Yeah, so we make a little blueprint here, and we do a little event graph here, and let's snap that back over there, and we'll snap you here, and we'll just do a little begin overlap, and when it begins overlap, we will spawn an emitter. Spawn emitter at location, and we'll just do it at the other actors, location, get, we can get our location, whatever. Get world location. And we'll just toss that in there. And the emitter is going to be explosion. And there we go. And we can play a sound or two, whatever, but this isn't the point of the lecture today. You know where I'm going with this. So basically, that's the old particle system. So before we can talk about Niagara, we should probably talk about the old particle system. The old particle systems were kind of like baked, right? So like that's, you walk in, boom, there it is. There's, every time something walks in there, it plays, a little explosion thing, right? And it's, you see how it's the same explosion every time? Stover, you see that?
Yep.
So every time.
Explosion, same spot.
Yep, same spot, same explosion every time. And they're really limited. Like you could do stuff with them, and people did, obviously. But they're limited. And so they came out with the Niagara System a couple years ago, and I don't remember exactly when. And I've been playing with it for a while. Not a lot, but like a while. And I'm actually really impressed with it. They rather than just kind of like a hard-baked particle animation, what it is, it's a whole system like of here, let me just pull one open. So like Flame Boy, which is that flamethrower effect you saw. You can see that over there. This is the particle effect. So when you right click, it shoots a flamethrower at the laser zombies. You see that?
Yeah.
Okay.
It's even moving in that editor too.
Mm-hmm. And so you can see there's like a timeline down here, and I could pause the timeline if I wanted, stuff like that. So what we have here is a system. Okay, so this is a particle system, and a particle system can contain multiple emitters within it, and it can have properties and things like that. It can connect to blueprints, and there's a lot of just cool stuff you can do with them. And I've only, like I said, I've only worked them a little bit, barely even scratched the surface of the particle effects. So let's get into this. So Flame Boy here, you basically read these things from top to bottom. Okay. So Emitter Settings, if you click on that, let me minimize my face. Emitter Properties. So basically, the particle effects kind of run from top to bottom, and there's kind of a certain order that you do them in, right? So like you have to spawn a particle first, and then the particle updates come after, and then the rendering comes after that. So there's like, and when you make one, like they'll kind of come in this order. And so what you can do is you can basically just kind of click on each of these things, and a lot of times they'll be minimized. You have to kind of like unminimize them to look at all the options, and you can mouse over them, and they'll give you more information on them and stuff like that. So the fixed bounds is needed if you're going to run the particle effect on the GPU. So that's nice, right? Like you want the GPU handling the heavy workload, and so you have to have fixed bounds on, and that limits the particles to a axis line bounding box within the world. And that's all that we really care about there. Yeah, so I switch it from running on the CPU to switching on the GPU, which requires fixed bounds to be turned on. Now we come down here to Emitter Spawn, and inside of that is Emitter Update. Let's see here. Emitter Spawn has nothing in it, I guess. And if you click here, that's the sprite. So it's drawing like little balls. Do you see that? So you can pick all sorts of stuff on this. I don't know if any of this is really matters right now. So let's go over to Emitter Update. So Emitter Spawn, let's see here, Emitter Update, life cycle mode, self, loop once, loop duration fixed. Yeah, so you can have the particle effects repeat over and over again. Like if you want to have a fountain, just is constantly producing water, you create the system once, and then it will just sit there and run forever. For the flamethrower, I wanted to do one puff of fire and then stop. So this is a, rather than an infinite loop or running 5 times, it runs once. Loop duration mode, it runs once. and it runs for 0.1 seconds. And here we go. Here's the spawn count. So if I were to turn the spawn count down to like 100 and hit play, you can see that this becomes a much more anemic flamethrower. You see that? Stover?
Yeah.
So basically, I wanted something very lush. And you can see as I increase the number of particles, there's just more and more dots. And of course, your frame rate cost is going to go up. That's 30,000 particles right there, which looks actually quite impressive, right? Kind of looks neat. So, and all right, so let's undo this. There we go. To what we had before. And you can see that as it runs, the number of particles actually decay. And the reason for that is because they have sort of a random fall off. And so if we go to the next thing here, emitter state, life cycle mode, yeah, that's the same thing, we're just there. Spawn burst. So spawn burst does like a poof kind of thing, right? Like an explosion, like a rocket hits a thing and it goes poof, like that. And then on particle spawn, you decide what is the physics of the particles when you create them. So like I said, you just kind of read these things like down, right? So you just kind of start at the top, you work your way down, and there's really a logical progression to it. And if you try moving things out of order, it'll like tell you to put it back in place. So on particle spawn, initialize particle. So if you click on particle spawn, you can see right here, lifetime mode, random, 0.5, 1.5. It's the same thing as this. Right, so this whole section will appear here, whereas you just click on each one of these individually. It's the same thing. So particle spawn is going to start off by initializing each of the particles by giving it a random lifetime, and that's why these things don't just go from 3,000 to 0, and they have a lifetime that range from half a second to 1.5 seconds. So that's why you see it kind of decay over time. It's kind of a cool effect. The colors are set to that orange color, and you can do a color picker and pick a different color if you want it to be blue or green or purple or whatever. Position mode, simulation position, mass mode, random. So it gives it a random amount of mass, and then the color, you can also do random colors as well. So you can have some of them be white, or some of them be purple, color, purple. So some of them could be purple. Like you see how it's like it's kind of hard to zoom in on this. So it's like a confetti effect now. So it's in a range from white to purple. It's kind of cool. So you do something like that. And we do maybe a darker orange over here. And you can have like checkered, kind of look on it. It's kind of cool. Undo. There you go. All right. So random mass. Sprite sizes are random also. So some of the particles are going to be smaller, some are going to be bigger, from 10 to 15. And if you want to make a really fine-grained thing, you can have them range from like 1 to 5, and the particles are going to be really small. You can have them range from 1 to 50, and so there's going to be a big mix of particles. Some are huge, some are small, and they get scaled. Oh, yeah, that's right, because it's a random width and height. So yeah, some of them are going to be tall and narrow, some of them are going to be fat. So you just do 10, 10, 15, 15, and then you'll get just kind of a little bit of variance. The human eye likes seeing a little bit of variance in particles. Like it would look weird if they're all moving at exactly the same speed, at exactly the same size, and vanishing all at exactly the same time. It would just like jump out at us as being unnatural, right? So put that back as it was. Yeah, question? Stover?
Well, when you say sprites, you do mean 2D images, right?
Yeah. So each of the little dots you see drawing there they're not 3D. They're actually that picture right there. So more or less. So it's drawing just a 2D, and it always faces you. So no matter where that flamethrower dot is on the screen, it's always facing towards the camera. And so, like, if we had the sprite be like a happy face, you'd see all these happy faces traveling this way, and it doesn't matter which way you're looking at it, the sprites always face the camera. And so you can't really tell on this because I'm making 3,000 of them, and I'm making them of various sizes, and I could make them of different colors, but all of those dots are always facing the camera. You just can't really see it because they all kind of blend together and have different speeds and lifetimes and things like that. So you could have them rotated at different angles, but in general, you want them like facing you. Okay. So add velocity and cone is what gives them that velocity. So if you wanted, I can make it have a minimum velocity of 1. So you see some of them just kind of lag behind, and some of them kind of shoot out. That's because they have a minimum velocity of 1 and a maximum velocity of 1,200. So if I set this up higher, you'd see all of them like fly up higher in like more of a ball shape there. And the reason why it's coming out in a ball shape is because the direction they come out in is random as well. If I had a cone angle of 0, they'd all fly out on top of each other. But with a different cone angle, you can have it, that's the width that the particles will randomly get spawned in. And it's really cool that it's doing this. It's very fast too. Like the GPU is able to handle large numbers of particles very, very quickly. You set this up to like 90, then you see it, the particles like have a 90-degree cone they come out in. And so all these things are just things you want to tweak, mess around with. So let's see here. 35. Yeah, there you go. Okay. And then the axis is which direction the particles come out in. And so X is the direction you're looking. At least it is in this case. And that's why the fires come away from you. If you wanted, you can have the fire go straight up. So like if you wanted to have like a smokestack or something, and you wanted the particles to fly upwards, then you could do that. And so you can choose basically the direction the particles come out in. And it's in your local coordinate space. So X is the forward direction, and so it comes out forward of you. And let's see if there's anything else here. So basically, it'll bias the particles to be kind of closer towards the axis than away from it. So it's not like an even distribution. And then there's a fall off towards the sides. Yeah, so you can play with all these values until it starts looking good. Add velocity from point. So what that does is it kind of pushes the particles out from a center point, so they go outwards. And so that's what you do with like an explosion or something like that. So let's make this like 1,000. Look, it's a rocket launcher explosion. You see that? What do you think?
That is actually, yeah, nice way to switch it and use it.
Yeah, it's just a really cool system. And like I said, there's so many like levels of depth and things like that into it that I'm just kind of running you through the basics that I've learned myself. I'm not really an art person, but it's fun to play with stuff. So, and then you can turn the things on and off too if you want. So like you can turn on add velocity and cone, and now it's doing both, right? So you can see it's like going forwards that way and also outwards, and so you can kind of combine them if you want. And so this will cause it to go forward and also puff outwards, and so you can create a cool like little puff effect like that. So like for something that goes out and radiates outwards at the same time. You can just check the checkbox and it'll turn them on or off. Right? So kind of cool. And then you just save it and try it out, see how it looks. And then add velocity. So basically what I've done here, and that's why the thing was going sideways when I had the velocity and cone pointed upwards, like this. The reason why it blows forwards is because I added velocity in the forwards direction. So if I turn that off, you'll see that the there. You can see it's going upwards and outwards. All right, so you can have like a smokestack that like spits out columns of fire, on a regular basis. It might be once every 10 seconds if you want. It's a very versatile system. And so I have it go forwards because that's the I'm making a flamethrower, right? So I want it to be coming out of the player. And you can add a little bit of velocity from point to kind of make it puffy. All right, particle state, kill particles when lifetime ends. So basically what that means is, you know how up here we have a lifetime min and a lifetime max? When it comes to the end of its lifetime, it automatically dismisses it. Easy. Call it a day. What would happen if we don't do that? Doesn't like it, I don't think. Yeah. I don't think it likes that. Okay. There you go. Okay. Gravity force. So you see how the particles kind of sink downwards a little bit, Stover? Like they kind of go out and they kind of droop a little bit.
Yeah.
So that's gravity going on right there. If we wanted to make it 980, that's like 9.8 meters per second squared or something. So then it's going to kind of come out like a garden hose. And I don't know, this could be fun. Let's do this. Explosion trigger. I don't need you anymore. Explosion trigger. Go away. Force delete. You're not wanted anymore. And save. And then let's try out the new Flame Boy. See, it's like see how it's like water now?
Yeah, that's pretty cool.
I mean, if that's the effect you're, I mean, it does actually look kind of cool. Like it's like this fiery rain.
Molten lava.
Be bathed in the fire of my righteousness. That kind of stuff. So, yeah. So you just toss it out there, and then it kind of drips to the ground like rain. It's pretty cool. Pretty cool. All right, where were we? Flame Boy. All right, so gravity force. We upped that a lot. Drag slows it down over time. So as it goes out, it kind of slows down. It basically simulates wind resistance. Now the color is like you can see how the thing like changes colors over time, and that's because the red I think decays down to 0 over time. So it kind of like it starts off glowing hot, and then it like kind of like fades off. And so you can play with the scale color so that over time the things will shift color, and you can have it go black, for example. That's in a video game I actually made. I would have fire that came out, and then it would kind of turn black and turn into smoke, and then dissipate. Like back in the day, I did a particle effect that did that. It looks pretty good. For this one, it just kind of the napalm kind of comes out, and it kind of cools off a little bit. Then it fades away. So it's I think the way that it looks right now is pretty good. But you can play with all these things. You spend a lot of time messing around with the colors and things like that. Solid forces and velocity just makes the stuff above work. If you don't have it, it tells you. It's like, yo, you need to make, like, you can't do gravity, right? You can't do you can't do drag, you can't do add velocity. None of that stuff works unless you have solid forces and velocity on. You just need that in there. And the Niagara particle effects system has built-in templates that you can use that just kind of put all the stuff in there. So it's like, what kind of stuff do you want? You want a beam, you want an explosion, and it'll just kind of put the pieces in that you need. If you want other stuff, there's all this stuff over here, drag, and yeah. So all those things can be kind of dragged in if you want. Usually, though, I just start with a template that looks like, kind of what I'm going for, and then modifying it. As you can see, I've modified this one rather, rather a lot. And then this is going to scale the sprites over time as well. So the sprites themselves, like you can see when they got really close, they look like ovals and things like that. That's because it is actually not doing a uniform scaling, and they sort of scale up like this and then down a little bit over time as well. So the particles actually get a little bit bigger and smaller. No, they scale by speed, right? So when they travel faster, they change sizes, basically. So kind of cool thing. At Event Handler, don't have any of those. Render settings, they're particles. The particles are aligned with their velocity, is that right? Basically, all that's just the default, I think. Yeah. And then sprite render, is there at the bottom, and that's it. So that's the Flamboy in action. And that's a simple thing. You just right click and fires come out, call it a day. Now, for the laser beam actually interacts with the world. And so let me launch that again. And so the laser beam actually, as you hold it, so the Fireboy just kind of sprays out, right? But the laser beam actually is doing a trace line, and whenever I click, it does a trace line to find out what direction the user is looking, and it draws the particle effect at the point that it hits, including a zombie, and the laser stops there. So you can see the laser gets longer and shorter based on, and it's got a maximum length as well. So I think that's out of, no, there we go, we're in range now, and now we're out of range. So you can see right there is about the maximum range of the laser beam. Okay. Can't hit the sun. So that's a cool thing too. And the cool thing is you can have your particle effect system tie in with blueprints. And so my player, if I can find you, where are you, zombie? Maybe it's under third person blueprints. Third person character. Yeah, I just left it in there for this one. I got grenades, got the heads up display, got sprinting, mouse, movement, flamethrower, laser beams. Okay. Gamepad. All right. Okay. So I should probably comment this. All right. So laser beams, check. So that's from Death Clock. Or meter. So I've set up an input handler. You know how to do that, right, Stover? How to set up an input action kind of thing?
Yeah.
Okay. You go to edit, preferences, bind it to the left mouse click. Okay. So, so when I click, it fires. When I release, it releases. So when I fire, it sets the visibility of Laser Boy. So Laser Boy is actually the laser right here. And it's actually... I think it's invisible by default. And so what happens when I click it is rendering actor hidden again. Where is Laser Boy? Maybe it's that right there. Okay. And so what it does is when I click, it sets Laser Boy's visibility to be visible, and all of its kids, which is the subsystems and all that, become visible as well. When I release the mouse click, then it hides it. So the laser basically turns on, like the laser's always there, it's just hidden. It's not doing anything. And so when you click, it shows it, and the laser activates. And what happens, so all this does when I click is that it sets a variable on me called firing. It shows the Laser Boy. When I release, it hides Laser Boy and turns off the variable firing. That's it. The rest of the stuff in here is actually called on event tick. So, like, this part is just the mouse handler. That's it. Then the rest of it is here. So, every tick basically... that's for the flamethrower. Okay. Firing. Okay. So if I am firing, then it grabs Laser Boy. And so as long as I'm holding down firing, then what happens is it grabs the forward vector of me. It multiplies it by the range of the attack, which is like 1,000 or something like that. I don't know. Where is range? Maybe that's a variable on Laser Boy. So Laser Boy has a variable on it called range. I grab that, multiply the range times the forward vector. Forward vector is always a unit. And so that gives me the destination. So from my position, from the position of Laser Boy technically, which is that point right there, probably should be attached to the end of the gun, either way. So from that position towards the direction I'm looking times whatever the range is, like 1,000 or whatever, that is the trace line. So I do a trace line from the beginning to the end, draws a line through the world. Every tick, it does this. That I'm holding down click. And if I hit something, if I hit a zombie, then I do shot damage to them. So basically, they get damage per second multiplied by delta time, so I don't do more damage on higher frame rates, right? That's what we talked about in class last time, right? Which is that a high frame rate can cause your damage levels to go up. And so every time you do anything on event tick, you must use the delta seconds to normalize it so that your damage is the same, no matter what your frame rate is. So that's basically it. Now, the Laser Boy itself is going to be doing stuff though. So basically, even if I didn't draw anything, this is going to be doing the damage, right? This is doing the trace line through the world, and it is damaging the things that I hit. Now the Laser Boy itself, if I come over here, is a event graph, and it's a actor, and it has a Niagara Particle system or two in it. And so what this is just that. Okay. So that is the what it draws when it hits a target. There's a glow of blue light, and then there's a fountain that comes off of it as well. And then the laser itself, you don't see it being drawn right now because the starting point and the ending point of the laser are by default the same. And so when you hide Laser Boy, none of this draws. And when you show Laser Boy, well, let's find out what happens. So every tick, when it's shown, it's going to do that trace line again. Basically, it's the direction it's looking times the range. So the particle system is also doing this. I probably could have them tie together a little better, but it doesn't matter. And basically, it's checking to see, did I hit something? If I hit something, then it takes the laser end, and that's the end point for the laser, and sets it to the place that I hit. If not, then it uses just the place that I was trying to draw to. So you see this pin here? I was going from my starting location to some point in space in the direction I'm looking. If I miss, that's the point that the laser is going to go to. But if I hit something, then that place that I hit is the endpoint for the laser. And that is going to set a vector parameter on the Niagara system. So this is the learning point for today. Okay? So
Daddy, when is my fencing lesson?
we're going to leave in 6 minutes, girl. So get dressed, girl.
No, Daddy, what?
It's at 5:20. Yeah. So this is how you tie together a blueprint with Niagara. And it's called set vector parameter, and you have to be very careful to spell the name exactly correctly with the correct capitalization and everything. Otherwise, it just doesn't work, and you have no idea why. And trust me, I stared at this thing for like a while. I'm like, oh, I didn't capitalize the E.
What are you teaching, Daddy?
I'm teaching how to make lasers, girl. It's too advanced and scary for a 9-year-old.
Is that why you pulled up in your Rudy?
so I set a parameter for the endpoint. So I'm telling the particle system, draw from your origin to there. I also set the visibility on the impact. So if I hit something, then I set the visibility to true. If I hit something, I set the visibility to true. If I didn't hit something, it does not draw the fountain effect. Okay, and it also doesn't draw the. That's both the cloud and the fountain. Okay. So if I miss, it just draws the beam. If I hit, it draws the beam and the explosion. And if I hit an object, the beam shortens. So the beam is always at the endpoint is always at the area in front of the player, out to the maximum range. And then I set the impact location. So this thing here gets moved to wherever the impact location is. So wherever I hit, that gets passed into here, and that's just in blueprints. The only thing here that is weird with Niagara is this thing here. I'm setting a vector parameter. And so if we zip into Niagara Laser here, you can see Niagara Laser has a couple parameters on it that can be set. First is the color, and that's the color of the laser beam. And the second is the endpoint. And so by default, they're all zeros. So if I were to show you what this looks like over here, laser emitter, you'll see that it has two parameters right here. So one is the color, and the other is the endpoint. And so that's the glue. That's the place where you can tie together blueprints. You can tie together Niagara systems. So in the Niagara systems, you can create a user-exposed variable. And in this case, I'm exposing a color, so you can change the color of the laser beam to whatever you want. I decided not to hard code it. It's like, maybe I want to have different people with different colored lasers. I don't know. I'll just make it a parameter. And then the endpoint will be passed to the emitter. And so it's going to spawn a beam. If we move this out of the way here. Let's see. Initialize particle. Beam width. Where are you? Emitter state. Beam emitter setup. Yeah, there. So absolute beam start is going to be the location of the emitter. And then the beam end is a user parameter. And so what I did there was just picked, you can just drag that over on top of that. And then that gives you a parameter that can be set from the blueprint. So every tick, the blueprint is setting the laser end parameter on here, and it draws a beam from its origin to the endpoint set every frame. And that is going, and these are absolute coordinates, not local coordinates. And that's it. So, so the beam start is just your origin, and the beam end is passed to you by the blueprint, and then it draws a beam bloop, through it. When you're doing development, you probably don't want to use this. You want to just use a dummy value of like 1 meter or something like that, so you can look at the beam and make sure that it looks good. Because right now, the laser end defaults to 0, which is the origin, so it doesn't draw anything. So, I don't know if you can even. There's got to be some way of setting the default to it, but I don't know. So that's it. Yeah. So if you want to view it, then you would set it to like some fixed value, and you can actually look at the beam. But basically, at the very end, what you do is you tie together the blueprint and the laser, and then it draws from here to there. And the rest of these things are all pretty straightforward. Spawn burst instantaneous. It just draws a beam. I don't know why I'm drawing two of them. It must have looked better that way for some reason. Spawn beam. Width is 15 units wide. I kind of played with that until it looked good. Beam twist, so you can make a twisty beam. Particle update. Yeah, basically all the same stuff. There's no physics or anything on it. It's a laser beam, right? And then we do a ribbon renderer here, so it draws a ribbon through the world, not a dot, right? And so this draws a ribbon, a rectangle, essentially, from the starting point to the ending point. And that's it. And so you can make one of these things by just making a new particle. Where are you? Particle system, like that. And particle systems use emitters. And so you make a particle system, and then you build an emitter. You build an emitter, and you put emitters into the particle system. So, let's do you. So Laser Boy is a blueprint class. The laser emitter is a Niagara emitter, and then it uses other Niagara emitters as well. And you can kind of, link them all here we go. There's a Niagara System here. Laser impact system, and that allows you to use multiple emitters within one Niagara effect. So I've got one that does the static ball. Just it's like a, I mean, I thought of this as like just a little dust cloud being kicked up by the lasers, and that's this one. And then so that's like a little dust cloud that gets kicked up by the lasers, and then the other one is the fountain of sparks. And so if you have a Niagara system, you can put multiple emitters together into it, bake it together. You can have parameters exposed on the system, and then the emitter properties can grab wherever the color is, spawn, particle, color. Maybe I'm not even using it, but yeah, you can use the parameter passed in here as the color. So you can have a blueprint change the change the particles on the fly, and or just have different players of different colored particles and things like that. And it's just a really cool, really powerful system. And your homework for the next week is to make some cool special effects in Niagara, and or using the free-to-play on the marketplace for the week. Marketplace, and this is for Krente, get well. Marketplace, there is a set of effects, and do you know if they're the classical effects, Stover, or if they're Niagara systems?
I believe they are Niagara.
Okay, then have fun playing with those, because they looked pretty cool. If they were the old effects, then they're just kind of like handmade and they just do their thing. You can't really do anything with them. With the Niagara system, you can change the colors and the positions and do all sorts of like really interesting ways. They can really interact with the world in a fascinating and fashion. I didn't have time to show you how I did the cool glowy effect, but basically you can pass in, rather than kind of randomly spawning in an explosion, you can pass a mesh to the particle system, and it'll randomly place particles on that mesh. And so you can have just glowy outlines of people. If you want a stealth effect, you can do that by passing the mesh, and then it just draws like some particles around it or whatever. So I layered a particle system on top of my player. So the player has his thing going on, and then he has a particle system attached to it that grabs the mesh of the parent and puts some glowy blue dots on it. So yeah, our RPG FX starter pack is free for the month. Grab that and just put together some cool stuff and just show it to me next week. All right, that's it for today. I've got to take my daughter to fencing. So thanks for coming out, Stover. I appreciate it. And Krente, get well.
Thank you.
And if you have any questions, just let me know. All right.
All right.
Cool. All right. See you on Thursday.
See you Thursday then.
All right, bye.
Bye, Kearney.
See ya.